Now, as I have alluded to in the last lecture, when you look at the series of events that are occurring during, the light reactions, you have the two photosystems, photosystem 2, photosystem 1, whoops, and then they are going to be linked by an electron transport chain. And then there's an abridged one at the end. Now, photosystem 2 gets hit by photon of energy, causes the chlorophyll molecules in the light harvesting complexes to vibrate at a different frequency. Frequency gets past chlorophyll A. Chlorophyll A gives up an electron, goes to the electron acceptor, and then it's going to go through this series of cytochromes, this series of protein complexes that are going to bleed off just a little bit of energy. Yes, I know I've said that so many times, but I want you to remember, evolution has had to come up with a way to counter, minimize second law of thermodynamics, okay? How to lower the amount of energy that's going to be lost. So this series of proteins and complexes in the electron transport chain are going to bleed off energy from the electron, the excited electron, pump a hydrogen, pass it on. Bleed in some energy, pump a hydrogen, pass it on. And then that electron that still has a little bit of energy but not a lot left gets passed to photosystem 1. Photosystem 1 also has been hit by photons of energy, is going to pass that energy onto the electron, which is then going to get bumped up physically as well as energy. And then it's going to get passed through this abridged electron transport chain, ending at NADP, P, remember plant, P, reductase. Okay, it's going to reduce NADP. Remember, to reduce is to add an electron. So, NADPH, which is, just like NAD we talked about in the last chapter, is an electron carrier. It's going to carry the excited electron to the Calvin cycle. So all of this we've seen here is just to harvest some photonic energy, turn it into mechanical energy, transport, and then at last we'll see it being used in the Calvin cycle. So hydrogens are being pumped from the stroma into the thylakoid lumen. Out here, we see that the hydrogens are at a low concentration, and in here, they are at a high concentration. So since we're going against we're going uphill here, we're going against concentrations, we have to pump. And to power the pumping, instead of using ATP, we see that plants have evolved to utilize photonic energy that's going to excite an electron. Excite an electron in photosystem 2. That excited electron gets passed through an electron transport chain, which is going to pump from low to high. That electron is going to get re-excited in photosystem 1. And then it's going to get captured and used to reduce NADP. Those high concentration of hydrogens are going to flow out through ATP synthase, just like we talked about in chapter 7, ATP synthase. As the hydrogens are flowing through, it's going to cause it to spin. As it spins, it's going to take a diphosphate and inorganic phosphate, link them together. Faster the hydrogens flow, faster the ATP gets synthesized.